what I'm going to do is I'm going to do 3 different cases for single lens ray tracing. You have some experience with that because where we left off last time is we did an object that was at twice the focal length. We imaged it through the lens, and it turned out that the image ended up at twice the focal length. So an image that started here ended up over here. Now notice what I did. Here's my image. It's this height over here without completely doing the ray trace over again. Basically, this is what we did. Take an image that's this, maybe this is what I'm trying to image, my hand in a C shape, right? Here's my object here. It got imaged through the lens, same size, magnification of 1, inverted on the other side of the lens at exactly twice the focal length. Started out at twice the focal length, ended up at twice the focal length. Okay? So I called this was a special case. This was an example of an image relay system where we're just relaying the image through the lens. Okay? Now, I want to take 3 different cases where the image distance is beyond twice the focal length, so somewhere beyond twice the focal length and infinity. The case where the object is between twice the focal length and the focal length, so it's in this space right here, an object space right here. And then the case where the object distance is less than the focal length. So when you see those 3 cases, you're going to be able to predict what's going to happen in image space. And this is helpful, number 1, to check your answer, and number 2, when you're laying it out on your paper to make sure you've got enough room. Okay? So let's take our object that is a centimeter high, that is 7.5 centimeters over here in the object space. To the left of the lens, 7.5 centimeters. Now my scale is 10 times that, so I'm 75 centimeters. The first ray that I want you to draw is a ray that comes from the tip of the object parallel to the lens. And then when it goes through the lens, it's going to be refracted towards the focal length on the other side. Okay, so now I'm going to, after I make this video, I'm going to edit it and speed this whole process up. So you're drawing and I'm drawing. So what I like to do is I just like to take the height of the image over here, which is a centimeter high, and I bring that over to my lens, centimeter high, because I know that then when I draw my line, it'll be parallel. Again, I'm editing out this portion of the video while I draw a nice straight line. And then again, I'm going to, the light ray is going to be refracted. The parallel light rays are going to be refracted towards the focal length. Goes through the focal length and it just keeps on trucking. I don't know where the image is going to be at this point. The second ray that I'm going to draw is going to be a ray coming from the tip of the object again, and it's going to go through the focal length on this side. A ray that's coming from the focal length is going to be refracted parallel to the principal axis. So I measure the height of the ray where it hits the mirror, and then I come over here some arbitrary distance, mark that same height so that I can draw a parallel ray. Oops. The book only shows you 2 example rays, and in fact 2 rays will converge at wherever the object is being imaged at. So now in green, I can mark my image. At this location. And I'll put an eye right here and indicate my image. If you want to check your work, it's like, well, I don't know about this ray tracing, Mr. Hey, I'm scared. How do I know that I did the right thing? Well, you could do the math. You can calculate your image location and image height. And you can draw a third ray which comes from the tip of the object, goes right dead center through the optic, and continues undeflected. Because a ray going through the center of the object is not going to be refracted. And in fact, you can see that ray is going to intersect where the other 2 is. So at this point, you raise your elbow high in the air and pat yourself on the back because you did a good job on this ray trace. So on our table, for an object that is beyond the radius of curvature, or twice the focal length, the image distance is going to fall between the focal length and twice the focal length. So here I can say xi is falling between the focal length and twice the focal length. Did I write those arrows right? I don't think I did. So xi is greater than f prime, and 2f prime is greater than xi. This is my xi location right here. Okay? And the image is upside down, it's inverted. And it's real. It's real because the image is formed by converging light rays. Okay?